Hi, this is Rahman Sheikh. Welcome to Fortnightly Railway Transportation Systems podcast. I am the host and railway systems specialist. This podcast is primarily focused on railway experts who have vast amount of experience and contributed greatly to this amazing industry. This is not a technical seminar but focuses on feel good stories, individual journeys, their success and failures, motivating younger generation to kickstart their career in railways and creating a sense of pride for the railway people who devoted their lives on the most environment friendly public transportation. Today on Railway Transportation Systems, we are joined by Navjot Chhabra, founder and sole director of Interface Rail Engineering, with over 25 years of experience in project management and engineering across India and Australia. Navjot specializes in delivering complex greenfield and brownfield rail projects. His expertise spans from project initiation through to operational handover, focusing on technical advisory services, design management, and client representation. Welcome, Navjot.
Yeah, thank you. Thank you for inviting me, Rahman.
It's a great pleasure to have you on the pod, Navjot. Let's deep dive into your technical expertise along with project management and entrepreneurial skill sets.
Yeah, let's go. Let's go for it.
Let me start with my first question. Can you share the story behind founding Interface Rail Engineering and its evolution over the years?
Okay. Look, Interface Rail Engineering was founded in 2005. So this is our 20th year. Next year in May 2025, we'll be completing 20 years of the company over here in Australia. So we've got 4 offices now: Melbourne, Sydney, Brisbane, and Perth. We've just recently opened an office in Perth. I started this company in 2005. I'm actually a third generation railway person. My grandfather started a company in India, which my family still runs. It's mostly in railway construction. So prior to coming to Australia, I migrated to Australia in 2003. Prior to coming to Australia, I was in India managing railway construction and track renewals work, mostly under traffic. Must have done thousands of kilometers of that in India. So when I migrated over here in 2003, I started working on rail projects. And at that time, I was working for one of the accredited rail infrastructure managers over here, being handed over the infrastructure being delivered by a project. So at that point in time, I realized that there was a need for someone to manage the interface between what the projects do and what the infrastructure manager or the operator accepts. So as the projects, get designed, get built, get handed over, there's a need for someone to represent who understands the operations and maintenance of the rail infrastructure, but also has a good understanding of the design and the construction of the rail infrastructure. So that's where I came in, then started this business in 2005. So back in India, I was doing the construction, mostly managing the field work, but also managing the proposals and all that were going in. Over here, started working for a rail infrastructure manager, and then slowly the business grew. So initially, it was mostly interface management between a project and a rail infrastructure manager who was accepting the infrastructure being delivered by the project. Then we went into different fields, strongly technically focused company. So even though we do project management, interface management, all of them are done by people who are technically very strong. So they've got the qualifications. In the company now, we've got about 90 people in the company. So we started with just myself in 2005, and slowly, progressively, we've grown. And now we are a team of 90 people. Out of that 90 people, about 40 of us are chartered engineers, registered professionally across different states. So realized that there was a need for technically focused people. There was a need for this service to be provided by someone. So we started doing technical advisory work. We are doing project advisory work, goes all the way from writing the project objectives all the way to actually completing and realizing the benefits of a project. We also do things like asset management. So what I was talking about till now was project related work, but there is the regular asset management of the rail infrastructure. So now we do a lot of that kind of work as well, where we are involved in managing the renewals of infrastructure, managing and developing an asset class strategy, corridor strategies for certain corridors of the network. But we also do things like condition assessment, right, technical standards. So that's the asset management side of things. And then along with all of this comes contract management. So commercial and contract management. So our people are not only technically focused, but they're also, they're techno-commercials. So they're also commercially focused. So you've got people who are technical, commercially focused, and are experienced. So the average experience across the company is about 20 years. So 90 people, average experience 20 years. So that's 1,800 years of experience in rail. So we only work in the rail sector.
It's a small team, but full of intellectuals.
Yeah, so, and then we've got things like operations interface, which is probably what makes us unique company, where we not only manage the design, the construction, commercial elements of it, we also manage operational impact of either a project being delivered or even of asset management activities. So by operation impact, things like how long the track or the network needs to be disrupted to be able to build, managing rail replacement busing, managing rail accreditation, interfacing with the rail regulator. Also look at things like operational readiness, where making sure once the infrastructure is handed over that it can be operated for our clients, making sure that they've got the appropriate level of staffing, they're prepared with the operational documentation, the regulatory documentation, all of that. So we started with interface management, and now that's where the name came from, interface rail engineering. It still stands very true, but we now do a range of services in the rail sector.
Great company and great intro, Navjot. Really loved it what you're doing to this industry. Since you spoke a lot about projects, let's deep dive into one of the most important or unique challenges which we have been facing, or tell me something you have faced while managing greenfield versus brownfield rail projects.
So, look, there are different things. In a greenfield project, generally, you've got a corridor and you're building a rail. So you're expected to be fully compliant. In brownfield environment, you've got constraints, which you don't have in greenfield environment. But in reality, regardless whether you're building in greenfield or brownfield, you're always limited by the width of the corridor. So that kind of limits you on certain things. I'll give you an example of track alignment. You may have a horizontal curve, which has to be compliant to standards of whoever is the accredited body managing that infrastructure. Now, the corridor may be wide enough to allow for that large radius curve, or may not be. In that case, you've got to even though it's a greenfield site, you still can't comply with the standard. So that's one of the challenges that you face. The expectation is that you're fully compliant, but you cannot always be fully compliant. But there are other things like, getting environmental approvals, often a big challenge to get started. It takes a fair bit of time. And then there is the final accreditation of the newly built infrastructure by the rail regulator or the regulatory body. They are the challenges in the greenfield environment. In the brownfield environment, it's mostly about managing the disruption to the operational network. So that's your biggest challenge, making sure that you are doing your work with no unplanned disruption and minimizing the planned disruption that you may be causing to an operational railway network. But the other challenge in a brownfield environment is also about complying to standards. So in a brownfield environment, it's, you've got space constraints, you've got technology constraints sometimes, you're interfacing with existing technologies. And so you've got this new piece of infrastructure that you want to put into an existing network, which, and both of them need to be able to, interrelate to each other. They need to be able to talk to each other sometimes, and that may not always be possible. So you may not be able to introduce the latest technology available just because the rest of the network cannot accept that new technology. So making sure the compatibility between new infrastructure and existing infrastructure, trying to do the best. You will have certain departures from standards, and you may have multiple departures from standards. And sometimes you've got to balance which one of those departures from standard is more acceptable than the other one. So there's a balancing act to be done. And then the impact to the operational railway, you've got to manage that as well. And I think we do it quite well, greenfield and brownfield. And we've been doing it now for almost 20 years in different environments. So we've done a lot of major complex projects, but we've also done a lot of small projects, which are very complex from interface point of view, greenfield, brownfield, regardless of how big a greenfield and project it is, it will always have some brownfield element associated with it because it's going to connect somewhere to an existing rail network.
Beautifully answered. I like the answer and I love the way you answered, Navjot. As you said, your company, you're moving more towards technical aspects as well. So how do you approach a project scope and technical specifications development, especially from a high level brief objective?
Yeah, very good question, Rayman. You start with project objectives. So whoever is sponsoring that project has certain project objectives. They generally come from a business case, but may not always come from a business case. So what are the project objectives? So then you go down from the project objectives and try and understand what are the high level operational requirements of a project. You then understand what are the high level impact of those operational requirements. So you start with project objectives, go to what the operational requirements are, then go with what are the impacts of those operational requirements. Once you've landed on what the final operational requirements are and what are the acceptable impact of those operational requirements, then you go into developing scope and technical requirements. And you do it in a structured way. Everything has to be linked back to your project objectives. So project objectives, then you get your client requirements being the next level down of what the requirements are that have to be managed. And then you go down further to define, those requirements in detail. You define scope from those requirements. You also define what are the technical parameters under which that scope has to be delivered. So the more definition you can then give around scope and technical requirements, the more certainty you have that what you're going to get back is going to be what you actually wanted to achieve to start with. So yeah, defining the requirement, defining the scope, and then managing the change. So as the project progresses, you've got to then manage the baseline that you've established for yourself so that you don't, if you have to go away from the baseline, and this could be taking on more scope or reducing scope, or losing the technical requirement or strengthening the technical requirement, whatever you want to do, that change has to be linked back to the objectives and has to be agreed upon by the sponsor. So you want to make sure that there is a control on the project scope
Yep.
and requirements. So you not only define it, but you then manage it well so that in the end, when the project is delivered, whoever is the end user of that project or whoever is going to then accept and operate and maintain that infrastructure is able to take that project back, and the project is then able to deliver what was supposed to be delivered operationally by that infrastructure.
Great answer, I should say. Very crisp, very short, and you explained it pretty well. And I'll move to my next question. Could you also describe your strategy of work staging and packaging on large rail projects?
So it's all about when you build a project, there are certain benefits, especially large projects. The large projects go on for a very long period of time. Most of the large projects will go on for a long period of time. So when you start the project, by the time the project is commissioned and fully completed, most of the large projects will take somewhere like between 5 and 10 years to get to that point. So what you have to do, the strategy of the works in relation to staging and packaging. Staging is to make sure that you are realizing the benefits of the project progressively. So say, for example, if you've already built a station and the station is able to be used before the entire project may be completed, you try and maximize the earliest possible use of the infrastructure that's being delivered by the project. So you try and realize your benefits progressively as the project progresses. And the staging is done either to allow the benefit realization. It may be done to manage of the project commercial risks associated with the project, or may be done to manage certain operational risks. Staging, is led by a number of different things. When you want to realize the benefits, packaging is led by certain elements in relation to managing your project delivery risk, managing your project operational risk, and also it's generally led by commercial and operational outcomes that you want to achieve out of the project. So there's a fair bit of thinking that goes
Yep.
in staging and packaging, and that is done in early stages of the project. If that has been done well, you reap the benefits of that through the entire project life cycle.
I do agree. I'll ask you a linked question on that. After staging and packaging, what do you think are the critical aspects of design and engineering management?
So design and engineering is generally making sure, in my experience, the bottom line, you design and engineer infrastructure in such a way that the residual risks associated with that infrastructure. So whatever you do, whatever you build, there will always be some residual risks. And those residual risks have to be accepted by the person or by the organization or by the entity managing that infrastructure. As long as you can build infrastructure, following that, so you've got the end picture or the end goal in your view in early stages when you're doing the concept design, when you're doing the detailed design of the infrastructure, of the network, or whatever you're building, of the system that you may be building. Eventually, someone's got to operate it, someone's going to maintain it, and it's got to give it benefits. So it's got to deliver whatever it was that you had started with as your project objective. So the design and engineering is generally managed from that point of view. Firstly, it has to deliver the entire benefit. Then it has to deliver the entire scope. And it has to do it with minimal possible risk to the people who would be operating and maintaining it. Or when I say minimum possible risk, that's probably not the right thing to say. It's probably within the appetite, within the risk appetite of the operator and the maintainer. So it may be a conscious decision for an operator or maintainer to accept a higher risk because there may be a lower capital cost. That may be the objective, but a higher risk which is balanced and has been thought through. Intentionally, a higher risk has been accepted by the operator or the maintainer. So engineering and design progressively, if you've got full project lifecycle experience, and that's where we do it well. Most of our people have gone through the full life cycle of a number of major projects. So they can visualize the completed project early on. They can visualize what are the downstream issues or risks that may be faced by the project going down. And engineering and design is when it costs you the least to fix those issues or fix those risks. So if you can design in such a way that eliminating those risks that may come, downstream, or you are managing it so that they are so far reasonably practical as the railway terminology that's generally used. That's probably the way a lot of that work should be done and is generally done.
Yeah, even Andrew Petre and a couple of other SMEs who came from assurance perspective, they focused a lot on that ALAP and SAFAP.
Yeah.
Apart from that, Navjot, your team, IRE, also supports the rail operator after the project?
Yeah, we specialize in that.
Beautiful.
So, we specialize in representing a rail infrastructure manager or a rail operator on a project.
In your answer to the first question, you spoke about project management and contract management. Can you walk us through the process of project and contractual management in a rail context, please?
Yeah, so there is a big overlap between the two, but they're two distinct things. Project management is all about managing scope, cost, time, and risk. So they are the four things that you manage on a project. So you're managing the full scopes being delivered within the cost, within the budget that you've got, within the time frame that you've got, and within the risk appetite that is acceptable to yourself. Contract management, on the other hand, has also got to manage the scope, has to manage the cost, but within the contractual parameters. So contract management is more making sure that you remain commercially compliant to the contractual conditions that you've been signed up to. You deliver the project within the contractual framework. So if there is a change in scope, there is a certain way to follow it. If there's a change in cost, there's a certain process to follow. Same thing with time and risk. Project management is looking at the whole thing, and contract management is generally a one part of the project management. In smaller projects, most of the project managers will also do the contract management. On larger projects, you would have a separate party because the workload is big enough to require a dedicated contract manager.
Great answer, Navjot. Really great answer. We spoke about project management, contract management, interface management, and also technical scope. Now, I want to ask you a question on validation. So, what methodologies do you employ for works validation, surveillance, and quality assurance on rail projects?
So, good question, Rayman. We have experience in doing all of that, right from design through to construction. It's very important to do actual validation, surveillance, and quality assurance on design as well as on construction. So if your design is compliant, it's delivering the entire scope. So you're making sure that the design actually is delivering the entire scope, is of a quality that can be used by the people in the field to build the infrastructure, and it doesn't have gap in scope, does not have intended or unintended departures from technical standards or technical specifications that may be project related. So you make sure that when the design is done, is fully compliant, it meets the scope obligations, meets the technical specification obligations. So you trace your requirements through the design. So that's one of the ways of making sure the design, that you've done surveillance of the design and quality assurance of the design. Now, once the design is approved for construction, then you want to make sure on site that the construction is actually done to the approved design. So to come to an approved issued for construction design, generally there's a long process that is followed. A number of stakeholders are consulted. There are things like safety and design workshop, the risk assessments that have gone through. And there are many things that get factored into the design that may not always be visible to a site person. So they may not have gone through that entire journey. And when it comes down to the site, in our observation, many times we've seen that someone in the field may decide this is an over design, and in a previous project I had built something in a different way. I don't think that it's required to do this additional piece of infrastructure, so they don't do that. They may or may not do that with good intentions, but the outcome, if it is not built to the approved design, then all that effort that went into building a design that had gone through all those steps is lost. So quality assurance is firstly to make sure that the construction is done to the approved design. Yeah. And then it's about workmanship. So you're out there trying to make sure that not only is it done to the approved design, it is done, the workmanship is appropriate for the infrastructure that is being delivered out in the field. And many times the design may not have looked at a particular aspect. There may be new things that come up on site and which have to be responded back. So there is a process then to change the design in the field while the infrastructure is being constructed. So if you're doing surveillance and quality assurance, it's also your obligation, or it's also one of your roles to make sure that that process is followed. Designs are not changed, without having approvals from the designers. The construction is done to a good quality workmanship. And not only is it done to a good quality workmanship, the quality assurance obligations are understood and are carried out progressively as the work progresses. So quality assurance on site, you've got an inspection and testing plan for a certain thing. An inspection and testing plan can be very well written or could be written in a way that it can just be a sham. Now, what I mean by that is if you've got to build something within certain tolerances, those tolerances have to be known on site. The people who are building it need to understand what are those tolerances under which you are required to build. But those tolerances have to be guided by the specifications and the standards. Template inspection and testing plan needs to look at all the particular activities by an experienced person who is experienced in construction. So all those activities are written down in a structured way.
Yep.
The acceptance criteria for each one of those activities is also written down, and who is the nominated person who has the authority to accept, whether the infrastructure has been, or the construction activity or testing and commissioning activity has been done within the tolerances. So what is the competency of the person who is allowed to sign it off? What is the competency of the person who's allowed to accept it? All of that got nominated in the inspection and testing plan. So there's a quality assurance management plan which says who is going to write the inspection testing plans, who's going to write the associated forms and the checklists that might be attached to an inspection testing plan, who's going to review it, who's going to approve it. And in the field, then the surveillance role becomes that the appropriate level of forms are being used, the competent people are actually carrying out those activities, and those approved forms are being populated progressively as the construction goes on. They don't get done at the end of the project when someone's sitting in a site office and trying to enter the inspection and testing plan. That's our role most of the times. We do that. And a lot of our people are able to do different things. So they may be working as a project manager, but during the design stage, they may be looking at design reviews. But when it goes into construction, they are able to carry out surveillance activities. And it's generally best to have the same person involved because there's always a lot of background before things are being built. So if you've got the same person going through the full project life cycle, they carry the intent with them. Some things are written, some things are documented, some are not. But having the person who's got the background knowledge probably removes some of that, side effect. Yeah.
There are two issues in this. One is either it's my suggestion that either we should involve the testing commissioning guys, at least a skeleton team right from the beginning of the process, or else if we use the same person, then again I think the question of independency arises because because he is the one who is writing the requirements and the same person designing and the same person is in the validation.
No, I'm not talking about the same person doing the design. I'm talking about the same person doing the surveillance. So the question was about surveillance and quality assurance. So if the same person is involved in the surveillance and quality assurance while the design is being done and when the construction is being done or the testing and commissioning is being done, they basically have the intent of the design clearly understood, because there may be things that are different. You have to, you encounter an unknown situation or a risk kind of eventuates when you're out in the field, and you have to make changes to the construction. Yeah. If you have the background, it probably helps. It definitely helps, in my view, and it helps with quality assurance as well. So yeah, I agree with the independence of a designer. Having an independent person look through the designs and all of that. I think that is an essential part of designing rail infrastructure. But in terms of surveillance, it's probably best to have someone who's been involved in design to be doing surveillance in design as well as in construction.
Beautiful answer, Navjot. Now let's move to the next question. What role does technical advisory play in ensuring the success of rail infrastructure projects?
So technical advice is engineering assurance. So, and many times it's engineering assurance, but it's also providing advice in relation to the technical specifications. We kind of making sure that a technical advisor would be involved, is able to write technical standards, is able to review technical standards, is able to document and develop project scope, technical specifications associated with the project, is also able to do a design. So a lot of our technical advisors are designers who have moved up, from doing design to doing design management to doing engineering management. So having experienced people who've done the design themselves, being as technical advisors, good experienced technical advisors probably helps with keeping everyone technically focused and technically focused towards a technical solution that would deliver what the project has to deliver.
100%. I concur with you, Navjot. Now I come to my last question. Looking ahead, what trends or innovations do you see shaping the future of rail engineering and project management?
That's a very, very broad question, Rayman. Rail engineering, asset management, project management, everything is changing. With the new technologies coming on board. One of the big things that you are going to see is mostly in asset management, which is going to have an impact on both engineering and project management. Things the way where the infrastructure is assessed, where the condition is assessed, and then the way the projects are scoped. Things like artificial intelligence, machine learning, remote condition monitoring. Now with the new technologies in place, you are able to do a lot of that. Previously, it required a lot of effort to do a condition assessment of an entire network. Now, not only can you do a condition assessment, you can also do a trend analysis of how the infrastructure is performing. I'll give you an example. I just recently read about a program, in fact, a technical service, which could look at things like, on a corridor, you've got the signal post, for example, and the signal mast. You're trying to assess the condition of a signal post and a signal mast. Previously, you would have to go and physically inspect each one of those signal masts and posts. Now you can have train mounted equipment who can look at each one of those signal masts and posts and actually evaluate the condition of those signal masts. So you could look at how much of signal mast is rusted, for example, how much of lean has it got, and then if you're doing it progressively, so if you're doing that recording every second month or every month, it'll tell you that in the first month the lean of a particular mast may have been, instead of 90 degrees, it was at 88 degrees, and now it's gone to 87 degrees. So there's a trend that, something is wrong. It's leaning. Could be something wrong with the foundation, could be something wrong with the mast itself. Yeah, so they are the kind of things that can be done. Now, instead of going out every 6 months and looking at every light pole, you could probably then say, okay, out of the thousands of signal mast or light poles or that I've got, I'd only need to go back and look at about 1% of them or 2% of them. And then that results in how much, what's your program, what's the kind of work that you need to do every year. So that's from the asset management side of things. But similar things apply in project management as well, and technical works as well. The BIM models that can be created for all the existing infrastructure in the field can save the project millions.
Yep.
And it is only possible because of the technology that has now enabled those things to be done. So I think it's constantly changing. You can design the whole network, or you can design a whole station, for example, in 3D now, and that allows you, it solves a lot of constructability issues,
Yep.
but it also makes sure that you don't have any clashes in your design. It helps with the interdisciplinary design reviews or interdisciplinary design coordination, and all of this is again possible now because of the technology. So that they are the changes that are coming up, very exciting changes in the next few years. I think railway project management engineering world is going to change significantly.
I do agree with that, and I think we should keep pace with that as well. And thanks for your time, Navjot. I learned a lot, and I think the people listening to you on this pod will have many, many takeaways, especially the entrepreneurs.
Yeah, look, I'm more than happy if anyone got any questions, or I don't know whether there's a forum in which you can or not answer those questions. But
LinkedIn.
yeah, I'll be happy to answer some.
Yeah. Thank you, Navjot.
Thank you, Rahman. Thanks for inviting me. And yeah, good discussion. I look forward to hearing many of your podcasts. I'm a big fan, Rahman, so keep up the good work.
Thank you. Thank you, Navjot.
Thank you.
I believe everyone listening to this podcast has got something to take away from today's discussion. If you like this podcast, please listen, follow, and share this podcast within your network. If you believe we should be sharing your story or someone within your network, there is a railway leader who should be here sharing his or her contribution to this industry, contact me on railwaytransportationsystems@gmail.com. Thank you for your time today. See you next fortnight. Until then, stay safe and take care of yourself.